Okay, so imagine like you're talking to your AI assistant, right? And it's not just, giving you those like canned responses.
Right.
It's actually like learning and getting smarter as you chat.
Yeah.
That's kind of the potential of what we're looking at today. LLM Inference-Time Self-Improvement.
ITSI.
Or ITSI, for short.
Yeah, it's a whole different way of thinking about large language models.
Okay.
Like traditionally, we've always focused on, size.
Right. Bigger is better.
Bigger models, more data, more computing power.
Yeah.
But ITSI is about making LLMs more efficient and adaptable right at the moment they're generating text.
So we're not talking about like retraining these massive models.
Right.
It's like happening.
It's happening in real time.
In real time, like as we're talking right now.
Exactly. Think of it as giving an LLM a set of tools that it can use to refine its own output.
On the fly.
On the fly.
So like an AI editor built right into the model.
Yeah.
I'm intrigued.
Yeah.
The paper that you sent me kind of breaks it down into like 3 main categories.
Yeah.
What's that first one?
So the first category is independent self-improvement.
Okay.
And this is where the LLM uses its own internal mechanisms to enhance its output.
Internal mechanisms.
Yeah, so it's not relying on external information or anything.
Okay, you give me an example.
Yeah, so one approach is called constrained decoding.
Constrained decoding.
And this is like, imagine setting rules for your LLM.
Rules.
Like imagine forcing it to include specific keywords.
Okay.
Or gently nudging it towards a particular topic.
So you're giving it boundaries, but in a way that makes it more creative.
Exactly.
Okay.
So one specific technique within constrained decoding is called neurologic star.
Neurologic star.
And it uses a set of logical constraints to ensure that the generated text adheres to certain rules or principles.
Okay.
So for example, if you're generating text about a historical event,
Right.
neurologic star can help the LLM avoid factual inconsistencies.
So it's like a fact checker.
A built-in fact checker.
But like on the level of individual words and sentences.
Exactly.
That's amazing.
Yeah.
Okay, so what other techniques kind of fall under that independent self-improvement?
So another approach is called contrastive decoding.
Okay.
And this is, instead of just picking the most likely next word,
Right.
the LLM compares multiple candidate outputs and selects the one that fits the best.
So it's like double checking.
Yeah, it's like second guessing itself.
It's second guessing itself to make sure it makes sense.
Exactly. And this can significantly improve the quality and coherence of the text.
Okay.
So there's a technique called PMI decode that leverages something called pointwise mutual information.
Wow.
Which is a metric that measures the association between words.
Okay.
To ensure that the LLM's responses are faithful to the given source material.
So it's not just like grammatically correct sentences.
No.
It's making sure that the actual meaning
It's understanding the nuances.
is being conveyed.
Yeah.
Okay, that's really clever.
Yeah. And then there's this thing called minimum Bayes risk decoding, or MBR decoding.
MBR decoding.
Which gets a bit technical.
Okay.
But essentially, it involves considering the overall utility of a sequence of words.
Okay.
Not just the probability of each individual word.
So instead of picking like the most likely word, it's thinking about
the bigger picture.
The bigger picture. So it's like when you're planning a trip.
Right.
You want the most efficient route.
Yeah.
You don't just want the shortest distance between 2 points.
Exactly. That's a great analogy.
All right. Yeah.
Yeah, MBR decoding helps the LLM generate text that is more strategically aligned with the outcome.
Got it.
Yeah.
So independent self-improvement, it seems like there's a lot of manipulation of probabilities and algorithms happening.
Yeah, it's about leveraging the inherent structure of the LLM and its training data to guide the generation process.
Okay.
But that's just one part of it.
There's more.
There's more.
Okay, I'm ready.
All right.
What else can these LLMs do to improve themselves?
Let's find out. So the second category is context-aware self-improvement.
Context-aware.
And this is where things get really interesting.
Okay, so it's like giving the LLM access to information beyond like its initial training data.
Exactly. It's like providing it with a reference library. It can consult in real time.
Okay.
So one approach that falls under this category is prompting.
Prompting.
Which might sound familiar.
Right.
But we're not talking about like basic prompts here.
Not just like write me a poem about a cat.
Exactly.
Okay, so what kind of prompts are we talking about?
We're talking about prompts that are designed to guide the LLM's reasoning process.
Okay.
So for instance, there's something called chain of thought prompting.
Chain of thought.
or COT for short.
COT, okay, break that down for me.
So imagine you're trying to solve a complex problem.
Okay,
You wouldn't just jump to the solution, you'd think through the steps involved.
right.
COT prompting does the same thing for LLMs.
So you're teaching the LLM to think step by step,
Exactly.
like a human would.
Like a human would.
Wow.
And what's amazing is that even a simple phrase like, let's think step by step, can trigger this more deliberate reasoning process.
So just that phrase.
It's called zero-shot code.
Zero-shot code.
Yeah.
Okay. Does that actually like improve the quality of the output?
Absolutely, by encouraging the LLM to reason more systematically.
Uh.
COT prompting leads to more logical and accurate responses, especially for tasks that require multi-step reasoning.
So it's not just generating like fluent text.
No,
It's actually generating text that makes sense.
it's about problem solving.
It's about problem solving.
Yeah.
Okay, cool. Any other context-aware techniques out there?
Yeah. So another fascinating approach is disturbed prompts,
Disturbed prompts.
which might sound a little counterintuitive.
Are we trying to like mess with the LLM's mind or something?
In a way, yes.
Okay.
So the idea is to introduce subtle variations or disturbances into the prompt,
Okay.
see how the LLM adapts.
I see. So you're throwing a curveball at it.
Exactly. It's like a stress test for its reasoning abilities.
And by doing that, what do we learn?
So by observing how the model responds to these disturbances, researchers can identify potential weaknesses. And develop methods to mitigate them.
So it's making it more resilient.
Making it more robust, yeah.
Got it. Okay. Any other context-aware methods you want to highlight?
Yeah, there's the straightforward approach of retrieval-based method.
Retrieval-based.
And this is where the LLM can access external databases or information sources in real time.
So it's like giving it access to the internet.
Exactly.
Like you can Google stuff.
Yeah.
Wow.
For instance, there's a method called KNNLM,
KNLM.
which uses a nearest neighbor search algorithm to retrieve relevant information from a massive database of text.
So it's like a built-in search engine.
Like a supercharged search engine.
Supercharged search engine. Okay.
Yeah.
That's pretty powerful. Imagine having an AI assistant that can just instantly access any information it needs
Right.
to answer your question or complete a task.
Right.
That seems like that could be really useful.
Retrieval-based methods are a game changer for tasks that require highly specific or up-to-date information.
Okay.
But wait, there's even more.
There's more.
There's one more category.
Okay, bring it on. I'm ready for the final frontier of LLM self-improvement.
All right, so the third category is model-aided self-improvement.
Model-aided self-improvement.
And this is where LLMs team up with other AI models
Okay.
to achieve even greater heights of performance.
Okay, this sounds meta LLMs collaborating with other AIs.
Yes.
What does that look like?
So one fascinating example is speculative decoding.
Speculative decoding.
Imagine an LLM having a junior writer quickly generate multiple drafts of a text,
Okay.
and then a senior writer comes in to review and refine those drafts.
So it's like a team of AIs working together.
Working together, each with its own strengths and weaknesses.
I love that concept.
So the junior writer
Okay.
is typically a smaller, faster model that can generate multiple drafts quickly,
Okay.
while the senior writer is the more powerful but computationally expensive LLM that makes the final decisions.
So it's combining efficiency with accuracy.
So-
Are there any like real world examples of that?
Yeah, so there's a couple of methods that implement speculative decoding.
Okay.
Speculative decoding and Spectre.
Okay.
They use different algorithms for generating and selecting the best drafts,
Okay.
but the underlying principle is the same.
Got it.
Yeah,
So we're like on the verge of creating entire AI writing teams
it's pretty amazing.
that can collaborate and generate content at an unprecedented pace.
Yeah, and that's just the beginning.
There's more.
Model-aided self-improvement goes beyond speculative decoding.
Okay.
Researchers are exploring a wide range of other approaches, including using expert models and even integrating external tools and APIs into the process.
Well, hold on a second. So we're already talking about like AI writing teams?
Yeah.
And now you're saying we can bring in even more specialized AIs and tools?
Yeah, it's a rapidly evolving field.
Okay.
But the core idea is to create a synergistic ecosystem of AI models that can learn from each other and work together.
It's like we're building the foundation for a future where AI is not just a tool, it's a collaborative partner.
Exactly.
That's really cool. But with all this power comes responsibility, right?
Right.
Like, what are some of the challenges or considerations that we need to think about?
Yeah, definitely as we delve deeper into this realm of LLM self-improvement.
It's like we're giving a toddler a chainsaw, you know?
Right.
They might be able to cut some wood, but
Yeah.
probably not a good idea.
There are definitely some risks involved.
What are some of those challenges that we need to think about?
So one challenge is finding that sweet spot between control and natural language flow.
Yeah.
We want to guide these LLMs towards better outputs, right?
Right.
But we don't want them to sound like robots just following a set of rules.
Yeah, it's like trying to teach someone creative writing, but giving them all these strict grammar rules.
Exactly. Too many rules and you stifle the creativity.
Right.
It's a delicate balance, for sure.
For sure. And I imagine like we've made some progress in understanding how these techniques work on a technical level.
Right.
But do we really understand how the LMs are making decisions?
That's a great point. And that's where more research is needed.
Okay.
To really shed light on those internal mechanisms and ensure that these models are operating transparently and accountably.
So it's kind of like a black box.
Yeah.
We see what goes in, we see what comes out,
Right.
but we don't really know what's happening
Exactly.
in between.
Yeah. And what about the computational resources required for all this?
Yeah. Are we talking like massive energy consumption?
Right.
Expensive hardware? Is this just for like the big tech companies?
That's a valid concern, and some of these techniques can be computationally intensive,
Okay.
especially those involving multiple models or large external databases.
Right.
But researchers are actively working on developing more efficient methods.
Okay, so making them more accessible.
Exactly, minimizing the computational overhead.
So it's like optimizing the engine of a car to get better gas mileage.
That's a great analogy.
We want it to be powerful, but we also want it to be sustainable.
Absolutely. The goal is to make these advancements beneficial for everyone.
Right, not just the people with the giant server farms.
Exactly.
Okay, so to kind of bring it all back to our listener,
Yeah.
what's the big takeaway?
The big takeaway is that ITSI represents a fundamental shift in how we think about AI.
Okay.
It's not just about building bigger models.
Right.
It's about making models that can continuously learn and adapt.
Even after their initial training.
Even after their initial training.
So AI that is more efficient, more capable, and ultimately more human-like
Exactly.
in its ability to kind of grow and evolve.
It's a glimpse into a future where AI is not just a static tool, but a dynamic partner that grows and learns alongside us.
That's really cool.
But as we've discussed, we need to approach this future with both excitement and caution.
Absolutely, being mindful of those ethical implications,
Right.
potential biases.
A need for transparency and accountability.
It's like we're exploring this huge uncharted territory.
Yeah.
You know, there's a lot of possibility,
A lot of wonder.
but we got to be careful.
We don't want to create problems we don't know how to solve.
Right. We've only just scratched the surface here.
Yeah, this deep dive has just scratched the surface of this fascinating field.
There's so much more to explore,
So much more to discover.
and we encourage our listeners to do just that.
Keep learning, keep questioning, and keep pushing the boundaries of what's possible with AI.
Thanks for joining us on this deep dive into the world of LLM Inference-Time Self-Improvement.
It's been a pleasure.
Until next time.